Here we are. Welcome back to Workshop Wasteland. I believe this is part 12 of this long 6-cycle oddball engine build series. We got some pretty neat pieces to make today. Kind of a rocker arm, if you will. We have an exhaust slider. Definitely some pretty fun operations to do. A little bit to learn about silver soldering. And, overall, just worked out pretty well. So, one step closer to this thing getting finished. As always, thanks so much for tuning in. I really appreciate having you here. And don't forget to like, comment, subscribe. Also, share it with some of your friends. I bet they think this is cool like you. Let's check this out together. We got a pretty straightforward milling operation here. We have to cut kind of a, I guess you could call it a tang onto this part. I have already zeroed in where I need to be, and we'll see how this goes. Alright, that's the first side. Like I said, this is an extremely straightforward milling operation. I forgot to hit record, but you can see I stepped this down a little bit. You leave 1/8 of an inch behind and round that off on the inside. You're supposed to use a 3/8 end mill, but I didn't have a 3/8 round over or 3/8 ball nose end mill, so I used a 1/4 inch, which I think will work just fine. Next thing we have to do is drill a hole back here and tap that for 440. So I'm not going to show you drilling this hole because it's literally drilling a hole, and I think you understand that. I'm going to drill this and tap it, and then we have to silver solder a little piece onto the bottom of this. I'm going to get that silver soldered on, and I'll bring you back whenever I get that done. I'm sorry, I'll bring you back whenever it's time to silver solder that piece on there. Hopefully that will go well. Otherwise you'd have to machine this out of a thicker piece of stock, which is silly. I'll show you in the plans why we have to silver solder this on, so it'll make more sense to you. But I'll get you set up over at the vise where we're going to do the silver soldering, and we'll go from there. Alright, I don't know how well you can see it, but I got flux on the piece, and I got that little tiny part right there held with a spring clamp, and we're going to silver solder it on. That right there is the little itty bitty piece of silver solder that we're going to use. Silver solder is expensive, and we only need it to fill that little tiny joint, so there's no reason to use more than that. Hopefully we can get that to flow into this part. This clamp's clamping it pretty hard, but hopefully not too hard. So I'm going to back the camera up just a smidge. Keep your eye on that little dot of silver solder in there, the bright spot. Well, it flowed in there, but my clamp messed up its clamping abilities, and now it's really crooked. Darn it. Silver solder flowed really nicely, but that's terrible. I should have put it in centered up in that clamp, I guess. Probably as it heated up, it sort of shifted, or whatever you want to say. So let me come up with something different or better or something. Probably going to knock that off. I'll heat it up and knock it off, and then we'll give it a second try. Alright, let's try this again. I again have a little speck of solder right there. You probably can't see it all that well in the camera, but I'm going to be using a torch, so I don't want it to get too close to the camera. And I'm going to try some safety wire to hold that little piece of metal in place. Well, that's not too shabby. Probably not absolutely perfect, but let me get you a look here. So it's pretty straight, basically flush with the end. Basically flush with the end. I think that's good enough. Let me clean this up and show you on the plans why we soldered this piece of metal on there like we did. If you look at the plans here real quick, you can see this leg on this piece. Okay, so you would have had to mill this out of a much larger piece of material and waste all of this. So instead of doing that, silver solder is pretty darn strong. And as you can see, that bright line all the way around is the silver solder. So you can see that little tiny bit of solder really makes a lot once it's melted. So don't be wasteful with it. It's pretty darn expensive. And I felt like this was a perfect time to put a plug in here. I started using this Safety Silv 56 along with this Stay Silv Flux. They make this in white and black. I don't really honestly know what the difference is. The white stuff seems to work really well for me. Maybe the black stuff would work better. But if you're silver soldering, spend the, whatever it is, probably 50 bucks or so, and buy these two products. I promise it's worthwhile. Let me show you the silver solder that I was using. This is some stuff from the hardware store. I thought it was going to be really good. It says silver bearing solder. Good luck getting this crap to work. I could never make it work. Maybe somebody else can. This Stay Silv 56 is awesome stuff. And then what I like to do, this is water mixed very strong with that Lemmy Shine dishwasher liquid, or dishwasher powder, I mean. As you can see, it's yellow, looks like urine, but it's mixed very strong. I like to pickle the parts before I solder them, clean off all of the dirt and debris, and it works exponentially better if you pickle the parts. I took this from Blondie Hacks. She has actual pickling liquid, and it always seemed to work well for her. So I did some research on the internet, and lots of people said citric acid, which is what Lemmy Shine is, works really well, and it definitely does. So now the only thing that's left on this piece is to drill a hole in the end of it and then round it off like you can see right there. I'm not going to show you any of that. It's pretty straightforward process. Drill and tap a hole. We still have to tap this hole, and then that'll be that completed part. This is the little exhaust push rod all done, minus we have to machine a notch in the back which gets marked off of the engine itself, and we'll machine that when we're ready to do like final assembly. That notch is going to engage that piece that we machined last week, which latches this open. I still need to find my 540 tap. I got that hole drilled in the end, but I don't know where the heck the tap is, so I'll find that. Next we're going to machine this little cam roller bolt. pretty straightforward machining operation, and it's done almost 100% on the lathe. I got a piece of 1/4 inch stainless steel rod clamped in the lathe here. I already faced it off. Alright, we need to turn this diameter down to 156 for the majority of this piece, and we need to go 394 long. So let's do that real quick. I think I'm actually going to slide that back in my chuck just a bit. That's a lot of stick out for this piece. That's basically 160. This is the little exhaust roller that I machined off camera, and we need that to fit, you know, reasonably good. Not really any slop in it. That's real nice right there. That's good for that. Now we need to thread a portion of that, and we need to turn that down. That's 172 long. I need to look up 440 thread, see what the OD of that should be. So the OD for a 440 thread is 112 thousandths, and we need to go 172 thousandths deep. Seems like an awful lot of clearance for our little wheel here. Gonna do a bit of an undercut here for the thread relief. Alright, now we just need a 440 tap. Then we can part that baby off. Sorry, I know I'm entirely blocking the camera on this, but sorta is what it is. Flip the die around in the holder and make sure it's tapped all the way to the bottom of the thread here. All right. Can check our little exhaust dealio here. That's gonna thread all the way down on. Throw that piece right in the garbage can, that's awesome. Alright, whenever it's snug, our wheel still spins, so we are Gucci. That should be just fine. Now the next thing we need to do is slide this out just a smidgen and part it off. So the head on this little bolt is supposed to be 3/64ths. Move in 90 for the thickness of my parting blade. 3/64ths is, just say 47 thousandths. So that is right there. Man, that's not much of a head on a screw. Turn the little nubbin off from parting it off. And the plans show for this to have a taper on it. I don't know if it's worth even trying to do that, honestly. I don't think it really serves any purpose whatsoever. Guess we can take some sandpaper and polish that up a bit though. Since you will see it. Yeah, that's not too bad. Not much to that little guy. So small I can barely even hold it. But there it is. Off camera, I have machined these two pieces to the starting dimensions. This is the pivot arm, just a piece of 1/8 inch cold rolled steel bar stock, and then this is the pivot pin. Something interesting, I don't know how well you can see, but you cut a bit of a groove in there, so whenever you put a set screw in there it doesn't tear this all up and then you can't slide it back out. So it was cool that they called that out on the plans. Now what we need to do is mill a slot across there and drill a reference hole in there for this piece to slide into and pivot. So these collet blocks, I don't know, you may or may not have collet blocks. They're really convenient for operations like this. So the nice part about a collet block is this one is 4-sided. I also have one that's 6-sided. But what we can do is mill across that flat, right? And then if we needed to turn this for a different operation, you could turn it and it would be exactly 90 degrees because this is a square block. Clamp this thing in the vise and use it just like this. These things are really handy to have. This particular size is ER25. They have them in all different sizes, tons of different collets, metric and imperial, square, round, all kinds of stuff. So if you don't have any of these, probably one of those things you ought to add to your Christmas list, since that's right around the corner and I know you've been good to Santa Claus. Alright, so I honestly don't know how this is going to go. This is an 1/8 inch wide blade, or slitting saw rather. 1/8 inch wide is an awful lot for this little machine. It's not super rigid, unfortunately, so I don't know how good or bad it's going to go. But what I did was put the blade down on top of the part, came out away from it, dropped down 125 because that's of course an 1/8 inch, and then moved down to the center of this pivot screw, and now we need to cut into that 9/32 of an inch. 9/32 is 281, so that's going to be a lot of cutting. I'm going to take a few cuts, probably time lapse some of this because I have a feeling this is going to be very slow, and I've never used a parting blade this thick. This is only about my 4th time using one at all, so we'll see how this goes. I first need to come in and touch off on this to get my 0 point. So that's my 0. Let's try 15 thou for the first cut. See how this goes. Well, that's a cut anyways. It's actually kind of amazing to me that these things work as well as they do. In all honesty, I didn't think that was going to cut that well. But yeah, there it is. Let's keep going. This is a 20 thou depth of cut now. All right, she's still smoking, but there it is. That's that cut. It actually did surprisingly better than I thought. I sort of think this slitting saw is a bit dull, but either way, that's the cut. That's what we needed it to do. Pretty happy with that. Well, I know it doesn't look like a whole lot, but these are the pieces we got machined in today's video. I did machine this off camera. There's truly nothing to it. Basically cut 2 tapers, drill a hole. That was super easy. I cross drilled that hole. Again, super easy, not really much to see. I mean, I can't show you every single cut and every single hole that I drill because this would go on forever. But, you know, it kind of is what it is at this point. And I don't want to drag it on too darn long. We did have some fun with this. Learned a little bit about silver soldering and the importance of kind of fixturing things whenever you are silver soldering. So, yeah, like I said, a little bit to learn there. Still have to machine a slot across that for it to be like a screw and be able to tighten it up or loosen it. But that's you know, one step closer. We're getting there slowly but surely. As always, thanks a whole lot for tuning in. I'd love it if you subscribed if you're not already subscribed. I'd love it if you leave a comment, ask me a question. Maybe there's something you want to see. Maybe you wish I did something differently. Maybe you just love the content and want to say, man, this is awesome, keep it up. Either way, I'd love it if you left a comment, click on the like video, and you know, share it to some of your friends. It would sure help out the channel. I would greatly appreciate it, and let's be honest, we could all grow together. Thanks again for watching. We'll see you next week.